The James Webb Space Telescope has just delivered the clearest pictures of Neptune ever seen, and what those images revealed has sent shockwaves through the scientific community. For decades, Neptune, the most distant planet in our solar system, was little more than a shimmering blue dot, a frozen giant swirling in mystery. But now, for the first time, we've witnessed something extraordinary, a massive object, dark and silent in the void, colliding head-on with this distant world. Captured in infrared by Webb's unparalleled instruments, the event unfolded like a cosmic drama. A body, likely forged in the icy reaches of the Kuiper Belt, plunged into Neptune's turbulent skies. In an instant, the planet's normally cold, calm glow erupted with heat and energy. Shockwaves rippled across its atmosphere, high clouds scattered in violent bursts, and Neptune's faint rings trembled under the force of the impact. To see such an event in real time is to be reminded of the fragile, violent nature of our solar system. These kinds of collisions were thought to be relics of the past, remnants of the solar system's chaotic youth. Yet Webb's images prove otherwise. Even now, billions of years later, giant planets like Neptune remain vulnerable to wandering bodies that drift through interplanetary space. This wasn't just a spectacle, it was a revelation. For the first time, scientists could observe how Neptune's atmosphere reacts to such a sudden injection of energy and mass. Layers of methane, hydrogen, and helium roared with turbulence as heat signatures spread outward, recorded in detail by Webb's infrared eyes. What had once been only a theoretical model played out in front of us on a planetary scale. And the questions are only beginning. What exactly was the object that struck Neptune? Was it a rogue asteroid, a fragment of a Kuiper Belt object, or something else entirely? Whatever its origin, it carried enough mass and speed to unleash energy on a scale rivaling countless nuclear detonations. The fact that Webb could capture this in such clarity doesn't just transform Neptune from a quiet, distant outpost into an active stage of cosmic drama. It also gives humanity a front-row seat to understand what such an event might mean. Here's a fully reworked and expanded version of your script. No hashes, no headings, just a flowing narrative with a bit more depth and dramatic storytelling. From a storytelling perspective, the image of Neptune being struck by a massive object feels almost mythological, as if the gods themselves were writing upon the sky. The very name Neptune was chosen by the Romans to honor their god of the sea, a fitting title for a planet of endless storms, swirling winds, and mysterious depths. To witness that world violently struck is to see a storm upon a storm, a titanic clash echoing through both myth and science. Yet what was once only the realm of imagination is now fact, etched into scientific record by a telescope orbiting far beyond Earth. With instruments of silicon, gold, and glass, the James Webb Space Telescope turned myth into reality. As the sudden flash of the impact faded into Neptune's cloud tops, the planet slowly returned to its deceptively calm, blue serenity. But those who witnessed it through Webb's eyes know that this was no ordinary moment. It was not just a discovery, it was an awakening. Neptune, silent for centuries, had spoken in the language of light and energy. Humanity, through Webb, finally heard it. The universe, so vast and seemingly quiet, is not silent after all. It is filled with sudden voices, and Neptune's collision has become one of those voices, echoing across the cosmic void. The event is not just an isolated spectacle frozen in time. It is a doorway into a much larger story, the story of planetary evolution, cosmic mechanics, and the choreography of matter in motion. Every collision carries meaning, every shockwave tells us something new about the way planets live and change. Neptune, the most remote of the 8 planets, has always been a sentinel at the edge of the solar system, a world caught between the known and the interstellar unknown. Its very discovery in the 19th century came not from direct sight, but from mathematics. Astronomers noticed Uranus wobbling in its orbit, tugged by an unseen giant. The irony is striking. A planet revealed by its invisible pull has now revealed itself through an unmistakable act of cosmic violence. Neptune sits just beyond the Kuiper belt, in a region crowded with icy remnants of the Solar System's formation. Countless objects drift there, small frozen relics, fractured worlds, and dark wandering bodies traveling on long, elliptical paths. Neptune's immense gravity makes it both shepherd and target. It shapes the orbits of many objects, steering them away, but at times places itself directly in their path. This latest collision is proof of that delicate balance. The planet is not just a passive observer of the Kuiper belt, it is a participant in its endless drama. The impact itself was immense. The object that slammed into Neptune likely carried speeds of tens of kilometers per second, unleashing energy on a scale unimaginable in human terms. Even a modest body, accelerated to such velocities, would release the equivalent of billions of tons of TNT. For Neptune, wrapped in thick layers of methane, hydrogen, and helium, the event was not just an impact but an atmospheric upheaval. Shockwaves rippled outward, storms shifted course, and chemical transformations may have been triggered deep in its hidden layers. Webb's infrared instruments translated this violence into glowing imagery, painting Neptune's skies with heat signatures and turbulence that spoke of chaos beneath its calm facade. Perhaps the most fascinating revelation lies in how Neptune's weather responded. This is a planet already known for extremes. Jet streams that roar faster than the speed of sound, colossal storms that make Jupiter's great red spot seem tame in comparison. When the impact occurred, Webb recorded pulses of energy that rippled across the planet like rings spreading in water. These surges did not remain localized but traveled across hemispheres, colliding with existing weather systems and amplifying their chaos. In those moments, Neptune became a living laboratory of atmospheric physics, showing us in real time how energy reshapes a world. That such an event was witnessed at all feels improbable. Collisions of this magnitude may occur only once every few centuries or millennia. The fact that Webb, still in its early years of operation, captured one is a stroke of cosmic luck and perfect timing. But it also hints at something more profound. Perhaps the outer solar system is more active than once believed. Perhaps Neptune, over billions of years, has endured countless such blows, each shaping its weather, chemistry, and even rotation in subtle but lasting ways. The legacy of this moment will ripple outward. For exoplanet studies, Webb's primary mission, Neptune's collision provides a real-world example of how giant planets absorb impacts. Many exoplanets orbiting distant stars are gas or ice giants, and their atmospheres likely bear scars from similar collisions. By understanding Neptune's response, scientists can refine their interpretations of distant worlds, learning to distinguish between storms born from internal dynamics and disturbances seeded by outside impacts. In this way, Neptune becomes not just a planet in our solar system, but a key to unlocking the mysteries of worlds light years away. Above all, there is something humbling in what Webb revealed. Humanity often imagines the universe as a quiet backdrop of stars, planets, and galaxies locked in slow, predictable motion. But the truth is far more dynamic. The cosmos is alive, filled with sudden upheavals, with beauty and violence interwoven. To know that a world more than 4 billion kilometers away can suddenly blaze with the energy of a collision is to realize how active and unpredictable the universe truly is. Neptune is no longer a distant, frozen sentinel at the edge of the solar system. It is dynamic, vulnerable, and vividly alive. What makes this discovery so remarkable is not only the impact itself but the enduring story it has begun to tell. The aftermath of the collision will not fade quickly. Shock waves will ripple through the atmosphere for months, perhaps even years. The chemical mixing and atmospheric disturbances unleashed by the impact will linger, giving scientists a rare opportunity to observe how a planet absorbs, redistributes, and gradually recovers from a cataclysmic event. With Webb's unparalleled infrared sensitivity, along with other observatories tracking the planet, every fluctuation, every thermal anomaly, and every evolving storm pattern will add to a narrative of planetary resilience and long-term transformation. Neptune has become a live case study, a laboratory in the sky, providing data that will enrich planetary science for decades to come. Equally compelling is how this event rekindles humanity's fascination with exploration. For years, Neptune has been largely overlooked, overshadowed by the allure of Mars, Titan, and Europa. Yet now, following the sudden drama captured by Webb, it has reasserted its importance. Scientists are already discussing the potential of dedicated missions, a probe sent to orbit Neptune, not just for a brief flyby, but for continuous observation. Such a mission could build upon Webb's revelations, unlocking the secrets of ice giants and their roles in shaping the solar system. The impact also sparks the imagination in ways that are both artistic and philosophical. To envision Neptune glowing with the scars of a recent collision is to see the cosmos as theater, a stage where forces far greater than ourselves perform acts indifferent to human timelines. Webb has become not only a scientific instrument but a storyteller, recording these cosmic epics for an audience spanning the globe. The collision with Neptune is one such story, dramatic in scale, resonant in implication, and unforgettable in its imagery. On a deeper level, the event serves as a metaphor for human fragility. Neptune endured a blow from a wandering giant. Earth, too, is vulnerable. Unlike Neptune, our planet hosts life, civilizations, and ecosystems that could be devastated by a similar strike. Witnessing Neptune's collision sharpens the urgency of planetary defense initiatives, asteroid tracking, and impact prevention strategies. The lesson is clear: the cosmos does not discriminate. The forces that shape Neptune, and indeed the entire outer solar system, could one day test the resilience of our own world. The James Webb Space Telescope was designed to peer into the distant past, to observe the origins of galaxies, stars, and planetary systems. Yet in recording a single, violent moment on Neptune, it has expanded its purpose. It has demonstrated that the universe's greatest dramas are not confined to distant epics billions of years ago, they continue to unfold in the present, even in our own cosmic backyard. Neptune's collision is a living reminder of the ceaseless interplay of mass, motion, and destiny. As this story continues, Neptune's name will echo through scientific papers, cultural imagination, and cosmic reflection. Once known only as a mathematical ghost, it has now become a stage for the most vivid display of planetary violence in modern observation. Webb's images will be studied, analyzed, and marveled at for generations, but beyond the data, the essential truth remains. Even the most distant worlds are not immune to sudden upheaval. Neptune, struck in silence across billions of kilometers of space, has spoken loudly. Webb has listened, humanity has witnessed, and the universe has reminded us that it is alive with motion, energy, and surprise. The significance of this discovery extends far beyond Neptune's clouds. It raises new questions about planetary magnetism, for Neptune possesses a magnetic field unlike any other. Its axis is dramatically tilted and offset from the planet's center, an anomaly long attributed to the motion of its deep interior layers. The impact may act as a natural probe, sending shock waves into the electrically conductive layers that generate Neptune's magnetic field. Subtle changes in the planet's magnetosphere could reveal previously hidden dynamics of its interior, turning a destructive event into an unprecedented diagnostic experiment. The collision may also influence Neptune's auroras. Like Uranus, Neptune's auroras are generated by interactions between charged particles and its irregular magnetic field. Material injected into the magnetosphere by the impact could intensify or reshape these auroral displays, offering future observers the rare chance to witness how a single event can energize an entire planetary system. Coordinated observations with other telescopes could reveal these celestial light shows, marking one of the first times humanity has seen a direct link between a catastrophic impact and electromagnetic phenomena on another planet. Even Neptune's climate could be permanently affected. Despite its distance from the Sun, Neptune experiences seasonal variability across its long 165-year orbit. These slow cycles have always been subtle, measured in decades rather than human lifetimes. Yet an impact injects an immediate burst of energy and turbulence, creating a sudden, artificial season that disrupts the atmosphere in ways the planet would not naturally experience for centuries. By studying these effects, scientists gain new insights into how sudden external forcing can shape planetary weather, offering analogues for exoplanets exposed to bursts of stellar radiation or flares. The physics of the impact itself is equally fascinating. Neptune's dense layers of hydrogen, helium, and methane provide a unique medium for shockwave propagation.